going to go through the daemon user settings file version 2.9.4. But here we will start with the start variables, and we have the Orca enable, which basically means if you're using Orca Slicer, you should have this set to true. This will enable all the additional features that Orca Slicer can provide to the macros. So if you're using Orca Slicer, set this to true. And the one of those features is the multi-surface option here that you have in Orca Slicer. So this requires you to enable it in the slicer, and then it will let you choose what sort of bed type and surface you have, and it will give you an option to select from 5 different ones. And what this will do is let you set a specific offset for each build surface, and it will automatically be called once the system sees a file with that bed type, that build surface, and automatically apply it. And we have here combine offset, so this will do a combination of offsets, so it will combine the offset you set for the multi-surface and also for any specific filament based offsets that we will see below shortly. And then we have floating fans, bed fans, and this is basically requires a temperature probe or sensor in your chamber enclosure type thing, and it will mean the system can have a floating point for the power level of the bed fans, and it will rise and fall automatically and be set automatically. And we have the maximum power for the floating bed fans of 0.85, and this is a scaled power between the low value and the high value, so it won't be a true 85%, it will be an 85% of the available power. And the option here is set flow to disable, and because the macros you are able to set a default flow rate. Here you can disable that so it completely ignores it. Manual leveling, if you don't have a Z-tilt or a QGL system, you can set it to level bed screws or bed screw tilt adjust, whatever it is. And then we have adaptive meshing. So this will use Clippers adaptive meshing, not Camp one, but the Clippers one, the inbuilt one. And when this is set true, you will need to do the stuff that's kind of listed here. But also when it's true, even if you have these set as false, it will force them true, because basically the printer won't know where the edge of your bed is in relation to the height of its print. So if you have a bed that's curved or misshapen, you can end up damaging your bed if you use the legacy static purge line and park. So this system will force adaptive purge and smart park true if you use adaptive meshing. If you turn this off, these can also be off as well, but if this is true, it doesn't matter what you set these to, they will be true also. And if you have an eddy probe, a BTT eddy probe, this is good to have, so it removes any chance of you saving an offset after the print. When Clipper Screen asks you, would you like to save the offset, this removes it. It doesn't give you the option. And then we have the Z tracker reduced monitoring. So basically, if you find performance of your system is impacted by the system maintaining a monitor on your Z height, you can reduce this so that the system only records your Z height at specific times and after specific actions rather than all of the time. So a few warnings here about all this sort of stuff, notes about setting it all up, blah blah blah. You need this So here we have the extended console logging, which is for both modes for adaptive pressure advance and bed fans macros here. So these will give a lot more information in the console about these two systems. Then we have the multi-surface build plate offset adjustments specifically for Orca Slicer, what we spoke about earlier. So you have the 5 different build surfaces here, and each one can be set with an independent and different offset, Z offset, that will automatically be applied whenever the macros see that you've sent the printer a file with whichever build plate. It will add or subtract an offset to your preference. So that's that there, and it will, you have limits. A minimum and maximum adjustment sort of things, so minus and positive adjustments. So yeah, and some notes and things, fairly self-explanatory. Now onto the filament settings. So we have 5 different filaments enabled here, and each one will have pretty much the same stuff. You have flow rates, high flow rates depending on layer size, which temperatures you want to preheat the nozzle to for each filament, chamber temperatures, minimums and maximums. If you have a chamber fan, an automated chamber fan, this will come on at this temperature, and anything below this temperature, the printer will heat soak the machine until it goes above this temperature, basically. So between these two ranges is your kind of ideal printing situation. And if you have bed fans, then the bed fans use kind of this and the temperatures to work out the settings it needs. And then you can say if you want this filament to use the bed fans and during the print, and then if you want them to help cool the build plate after the print is finished, and then bed fan speeds high and low if you're not using the floating settings. These are the kind of the basic minimum and maximums that will be used. Never more speeds for during and setting up of the print, etc. Pressure advance and smooth times for the filament, and then if you're using adaptive pressure advance, you can set this to true or false here, so it will be used or not, and then your settings for each extrusion type. So that's that, and here you can see the ASA ones, very similar. The ABS ones, very similar again. But you'll notice here we have an additional section here, which allows you to set a filament-specific offset. If you're high temperature, so if your offset changes as you go up in temperature, away from the standard PLA heat range, you go up to the ABS, ASA heat range, you might need to apply an additional offset, and then if you go back up to the top of the page, we had the combine offsets. This will then also combine the build plate offset with this offset, but it will also double check that you are not exceeding this maximum. So we have PETG as well, and this has an anti-squish, so this goes the other way. This only allows you to add a positive offset because it doesn't like to be squashed quite so much as PLA, etc., etc. So, and if you do too much, then it welds itself to the build plate and you won't get it off. Same basically goes for TPU. There's a positive adjustment there. And lastly, we have default values for unassigned profiles. So if you send a print for a filament that is not in the list above, then it will use these settings. The first one, which is home the y-axis first, true or false. So you can choose your homing order there, so it's fairly easy to figure out. And also the override home power safety option. So if you want to disable the 1 amp power limit for actually homing your system, you can set this to true, and you can set whatever power you like. With it false, it will only let you have a 1 amp setting or less. So yeah, here we have the homing power setting. So by default it's set to 0.7, and then we have a homing lift, so it will lift the z-axis by whatever amount you put in here, and by what speed, millimeters a second. And then you have the axis back off speeds, so when it homes and it hits the end stop, how fast does it come back away from the end stop, and to what distance. Also, if you're using sensorless homing, it's good to have a register clear wait, so you let the driver registers clear before you start the next homing process. And then obviously we have a homing movement travel speed. So this one basically sets the speed of the tool head to move to the z-axis end stop or probing location. So once it's homed x and y axes, how fast does it move to wherever it needs to go to home the z-axis. Right, and if you have a custom probing point, or you'd like to use the default one, so basically the center of the bed for most instances when set true, but if you set it false, you can use these custom points here and set a x and y position to wherever you'd like the probe to home on the bed. You can have it front left corner, rear right corner, wherever you like, basically. But these are not to be used for end stop switches. These are on the bed probing, basically. These are just custom locations for on the bed. The end stop switches for Voron style printers are here. So, if you'd like to have the switch back off here after you've homed Z, you can have this set true as default, and this will move the axis away from the rear of the printer. So if your switch is right at the back, like a millimeter away from maximum travel, this will move it away. So if you have to home with it in that location, it won't bang or grind. It will have a bit of a chance to register the stool. So there we have the distance in the y-axis for it to move, and the height you want the gantry to go to afterwards. And then once you have that done, you can set the position of your end stop switch here by replacing the 8s by putting in the axis location for your switch. So obviously you have to be careful when setting that. There we go. And we have toolhead parking settings, and this will be used for when you start a print and it's running the print start macro. If you want a custom park location away from the default one, which is basically in the center of the bed and at a specific height chosen by the printer depending on what end stop or probe you have. So if you'd like to override those settings, you can set this to true, and then you can let the system choose the Z height to park at, or you can choose your own, and then you enter the values in here. We have pause and timeout options. First variable is infinite pause. By default set true. What this means is if you set it up properly, after a 10-minute timer in pause, the extruder will be powered down, but the motors and the bed heater will be left on for the duration of the pause, basically until you unpause it or cancel the print. So it could be hours or days, hence infinite pause. You also have a kill fan on pause option. This is also set true by default, and what this will do is it will automatically turn off the parts cooling fan for the duration of the pause, and automatically turn it back on to the previous setting when the pause is stopped, when you resume the print. So a few notes here about this system. So that's that. Present and stow toolhead macro options. So these are basically where you want it to go to when you press present toolhead, and these are where you want it to go to when you press stow toolhead. So it's usually good to put them, like at the back near your cleaner, not a brush or pad, or or a purge bucket or something like that. And this kind of is kind of like in the middle at the front of the printer sort of thing. So we have filament change, load, unload macro options. So filament change parking locations, X, Y, and Z, fairly self-explanatory. How much filament you want it to load, and purge, and same for unload there as well. Printer heat soak handling. So what this one I get asked about a lot. Start my print already. So if you don't want to heat soak your printer, if you were in a rush and you want to totally bypass the heat soak, and all print start calls, set this to true. So basically your printer will not heat soak or wait for any temperatures other than nozzle and bed. It won't do anything. You set that to true and it will bypass it all. But you also have an option on main sail in the main window, the heat soak toggle. So if you set this true so it doesn't heat soak, but one time you want it to heat soak, you press the toggle, and for that session it will heat soak until either you turn it off or you restart Clipper, and then it will default back to your saved value here. So this is the most popular. Where can I turn this off? It's that. So yeah, there's that. And also, if you have a thermistor in your enclosure or chamber, you can use temperature weights instead of timers for your heat soaks. So this will basically wait for a specific chamber temperature for your printer, rather than just a dumb timer that counts down. It knows how warm the printer is. So if you're 5 degrees off, it will heat soak for a minute. If you're 15 degrees off it, it will be a longer one. That kind of thing. So yeah. Then also, if you have a chamber fan, an automated chamber fan, it will, on the end of the print, it will set this temperature to cool the chamber down to, and run the fan until a couple of degrees under this temperature. It won't be exactly this temperature. It's just the way Clipper works. If you set it to 25, it'll stay on till 23, because it assumes that once the fan stops, it will warm up a little bit again. So yeah, these are other options here in relation to the heat soaks. These are the low temperature timers and the high temperature timers. So PLA, PETG kind of stuff like that. And this is the ABS, ASA kind of high temperature stuff. Beds over 90 degrees. And these are used if you have this set to false. So there's that. And right, now here we have another thing which is fairly dangerous if you don't do it correctly. The Voron guys actively discourage chamber heating. So use this at your own risk, basically. Lots of warnings, lots of stuff saying, the results of this are on you. So that's that. You have to agree to this and enable the system to be able to use it by setting this to true. If you don't, it will just error out all the time saying you haven't set it up, you haven't agreed to this. Whether you have a NeoPixel on your heater to indicate any power levels and things like that, you can set that to true or not. And then also you can have your power temperature levels, should I say, here. Nevermore post-print settings, whether you want it to only cool down, activate after a print for high temperature prints. There's that, especially to dissipate any toxic fumes inside the chamber. If you want it to do it all, you just set that to false. It will do it for every filament, every print. And you set power levels and timers, run times. If you want to use the timer at all or just leave it running, there's options there too. Also here we have mains power relay settings. So if you have a shutdown relay attached to the mains power of your printer that is capable of turning it on and off automatically, these are the options you need to change. If you have an all-in-one system, an integrated system where the Pi is on the main board and there's one power supply, you need to shut this system down correctly first by setting this true, and this will shut down the Pi safely and stop all the ClearFair services and everything. And then if it's a BTT relay, it will automatically shut down once it's no longer receiving the stay alive command from Klipper. So this is the one to use for something like that, an integrated system. But if you have like a Raspberry Pi and a separate main board, leave this false. Then you don't need to shut down. You don't need to shut down the host, the Pi. So yeah, there's that, and choose whether you want to power it off. If you have a separate Pi, you can do it there too. And if you want to also, once the printer reaches the hour-long timeout time, you can set this to true, and the relay will power down the printer itself automatically at the timeout time. So a few notes and things about that. Right, other section, variable feed rate, default feed rates if you want that changed at all or not. So best to leave that at 100 really. Printer lights, power printer lights, for starting a print, you want them on full so you can see what's going on, and when it finishes you can set them to a low power or even zero, turn them off. And if you have a stealth burner or any other tool head with LEDs, NeoPixels, you can set them to turn off at the end of the print or leave them on, up to you. Purge lines, so whether you want to purge or not, if you want to go straight into the print, you can set this to false, and it won't do any purging at all. Then there's also the legacy static purge setup, where you can choose which axis to purge along and positions and length for that purge. So this is not adaptive. This will be on the edge of the bed, either along the Y or X axes at your chosen locations. So there's that. Hardware options, basically this is the section where you tell the macros the setup of your printer. Do you have a clicky probe, a chamber fan, a chamber sensor, a chamber heater? It kind of goes on to go through the list. Some notes about this sort of stuff here. It's good. You can't have both a chamber fan and chamber sensor set true, otherwise the system knows and it will error out. You basically you need to have one or the other. You can't have both. So bed fans, run out sensors, encoder run out sensors, like the BTT smart sensor, that senses when there's the filament's not moving. Nevermore shutdown relays, printer lights, NeoPixels. If you have a nozzle cleaner pad or brush, purge bucket, and the AES system, which is really specifically for Vorons, which there's links and stuff in the GitHub page for all of that, and stuff here as well. It's an automated emergency stop system that will shut the printer down if it senses that the printer has missed the Z end stop switch for any reason, and the nozzle is going lower than the activation point of the switch. during the homing process of the Z-axis. So basically what this means is if you're using, say, sensorless homing and something gets in the way, or it doesn't go all the way to the end, and then the tool head moves to a location that's not above the end stop switch and it starts to descend, it will trigger the AES system and stop the printer from basically trashing itself, and lowering so much and just grinding out, because it can do that. And also, if the nozzle only just slightly misses the end stop switch, like, if it kind of touches on the edge, or the heat block triggers it, if it's only a few millimeters out, this will completely throw off the Z level for the printer. So when it starts printing, if it starts printing, it will try and put the nozzle through your bed to the level it was when it homed. So if it hit the heat block, it will try printing with the heat block at 0 instead of the tip of the nozzle, and that's serious print damage. That's trashing your bed. That's trashing your nozzle, your heat block, your hot end probably. And not only that, it will be putting a whole load of force and strain on your linear rails and the gantry system of your printer. So it's basically a printer saving device. And if you have a Voron with a Z end stop switch, I highly recommend you look at this system. Head to the link and read about it. And it's not very difficult to install. It'll cost you hardly anything, a relay and an induction probe. And that's about it. Okay, moving on. Welcome messages. If you want welcome messages to be displayed here, you can set your own or just leave them like that. Version number of the file, you don't need to mess with that really. And here we have the mesh builder options, bed temperatures for each filament, heat soak thresholds if you have a thermistor, timers if you don't, use bed fans or not. And we have Z calibration variables, nozzle preheating temperatures, heat soak timers, and temperature thresholds. So yeah, there we go, end of file. Thank you very much for watching. Hope it wasn't too boring, and happy printing.